Hi, we are going to discuss the second part of units and measurements chapter. First part we have discussed why we have to measure, what is a need for measurement, what is called a unit, and the fundamental units, derived units, etc. we have discussed. Small distances, small measurements we have seen. That is diameter of the wire, how to measure, or small sphere diameter or radius, how to calculate using screw gauge and vernier calipers, we have discussed. Then we have given some basic introduction for dimensional formula. And now we are going to discuss slightly a different topic in measurement. That is, 4 different topics we are going to discuss today. Number 1, measurement of larger distances. And number 2, what are called errors in measurement. And number 3, what is called significant figures and rounding off. And finally, uses and limitations of dimensional method. Okay. We will give some examples also for dimensional formula uses. Some problems we will discuss. Okay, fine. Height of a tree, approximate height of a tree, we want to measure by triangulation method. Triangulation method. Suppose this is a tree of height h. Here we have the observer O, AB. From the observer to the base point of the tree, you take it as x. This is 90 degree. Our aim is to calculate AB distance, that is the height. How will you measure? Calculate tan theta from triangle BOA, calculate tan theta, that is opposite side by adjacent side. Opposite side is h, adjacent side is x. Our aim is to calculate h, so I can write h is equal to x tan theta. So this is called approximate height of a tree. Say for example, you want to measure, that is h is equal to x tan theta. Okay sir, parallax method. I want to measure the distance of a planet. Approximate distance of a planet we have to measure. Here one important point you have to keep it in mind. When you are measuring any distance from the earth, the planet size will be enormously high. But when you are measuring anything from the earth, you have to assume that one as a single point. That point only you have to observe. As a point only you have to observe that one. So this is a planet, say P. 2 positions of the earth you want to measure. So this is theta. This is AB. This is called base, basis or base, B. This you take it as x. Actually, this is called arc length. Arc AB is equal to, you have already learned, arc length is nothing but product of angle subtended into radius. What is angle subtended here? Theta. The radius here is x theta. arc AB is equal to x theta. So x is equal to arc by theta, you can calculate. Simple. This is called parallax method. All these things I am giving only introduction. Okay. Fine. Next. Radar method. Radar method. What is called radar method? Suppose you want to find out where the particular ship has gone, where the particular aircraft has gone, which has got disconnected from the base station. You are sending a pulse, radio waves from the receiving end, from the transmitting end, which will go and hit that particular object and then return back. Based on that, you can calculate the distance. How to calculate, sir? Distance is equal to velocity. Velocity is distance by time. So distance is equal to velocity into time. Sir, here we have radio waves. This is the target. This is the radio wave, what you are sending from the transmission end. So the distance will be c into t by 2. The distance is equal to velocity into time only. Why you are putting by 2? Actually, we have to measure only this point. But the pulse is traveling from here to here and then return back. Time only you have calculated. Forward time alone we need. Forward and return journey together time we have calculated. So we are dividing by 2. Time we have already taken 2 times, so we are dividing. That's all. Okay. Fine. Second part in this is types of errors. Errors in measurement. Of course, all measurements, whatever you are calculating, definitely possess some errors. Man-made errors we have, instrumental error we have. Due to the surrounding atmosphere, you might get the error. So you cannot completely avoid. No instrument is 100% efficient. So two types of errors only we are going to discuss here, where you can sometimes minimize the accurate value. Minimize the error. You cannot eliminate the error. So that to get the accurate value. Accurate value is our aim. So only we are doing the practicals to get that particular value, to do the calculation. Finally, we are getting the result. That result should be error-free. At least it is closer to the correct value. You may not get the correct value all the time, but it is closer to the correct value. For that only we are doing. Okay, random errors. Sir, control is not with yourself. Randomly error is coming. Surrounding temperature is increased suddenly. When you are doing some experiment, that experiment itself, some temperature increase, 1 or 2 degree temperature increase. Because of that, we are getting a wrong value. power fluctuation, voltage fluctuation we have, because of that some error. So like that and all, we have some errors that is called random error that you cannot avoid. It is not in your hands also. So what we have to do, you are calculating simple pendulum experiment, calculating the value of acceleration due to gravity. Your teacher told, take different length, 50 centimeter, 60 centimeter, 70 centimeter, 80 centimeter. You take different values. Calculate the time taken for 10 oscillation. Do 2 trials. Take the average. Like that, teacher will say. Calculate time period using that. Time by number of oscillation. 50 centimeter we are taking. We are getting oscillations. The time is, say for example, 14 seconds for 10 oscillations, 50 centimeter length. Time period is 14 by 10, so 1.4. Then why you are repeating another trial? One oscillation is enough, no? Time taken for one oscillation only you are calculating. Why you are going for 10 oscillations? For that you are taking a second trial, average 4 distances. Why? To avoid random error, to minimize this random error. So we are calculating so many values, observation values, x1, x2, x3, n readings. Divide by number of readings. That answer will be closer to the correct value. It is not the correct value. 1.4, 1.38, 1.36, 1.41, 1.42, like that I am getting. 1.4 is not exact value. So take so many values, take the average. That value is closer to the correct value. It may not be accurate, precise. Okay. Random errors. Gross errors. Personal errors and all, we call it as gross errors. Sir, stop clock when I am using. Stop clock is different. Stop watch is different. Stop clock I am using. Check every time when it is coming to 0. Sometimes it may be in 2 seconds. So bring it back to 0, then you do it. If you are avoiding that, that 2 seconds will be extra, no. That is your problem. Apparatus is not. You have not set the initial adjustment. Initial adjustment is not done. Improper judgment by the observer. Elongation of a spring experiment, when you allow the spring to elongate by keeping the mass, you are measuring the scale reading 14.2 centimeter. Simply you put it is coming at 14.2, sometime moment you put it will oscillate. You allow it to come to rest, then you have to measure. Sir, it is coming within 14.2 and 14.5, sir. 14.5, wrong. It is your problem. So gross errors is completely due to mismanagement of the observer who is doing the experiment. Okay. These are the two main topics in errors. We have instrumental errors also. We have constant errors. Percentage error, how much percentage? Percentage errors also we can say. What is percentage error? Say for example, I am measuring a distance of one particular wire. The length is 25 centimeter. I am measuring using a scale. Already I have a scale. Using that scale, I am measuring that value. Some other scale, 24.8 only I am getting. Another scale, 25.1 I am getting. Sir, same scale, I will get 25, 24.8, 25.1. Some scale, exactly that 0 is you have not measured. That 1 millimeter it is showing the error. So percentage error means percentage error is delta x by x into 100%. X is a total value, say 25 centimeter. You are getting error of 1 millimeter. 1 millimeter means 0.1 centimeter into 100%. Centimeter get cancels. So you will get 0.1 into 100, 10 by 25. 10 by 25 percentage. That is 2 by 5. 2 by 5 is 0.4. 0.4 percentage is very much less. No problem. 25 centimeter, I am measuring only 23.5, sir. 1.5 centimeter is more. 1.5 centimeter is total value. 1.5 centimeter plus is total value. So what is delta x here? 1.5, this is 25 into 100%. So this percentage is more compared to this point. So you are getting 150 by 25. 6%. 6% is very, very, very high. Less than 1 or 2%, no problem. Percentage error. Okay, Mama? Fine. Next. Significant figures. What are called significant figures? Already we have learned the basic. Number of meaningful digit in a number. Number of meaningful digit in a number, you call it a significant figure. 1, 2, 4, 5. Number of meaningful digit 1, 2, 3, 4. 4 digits. So significant figure is 4. Sir, I am getting 1005. How many significant figures, sir? 4. Sir, 0 is not significant. Absolutely correct. 3000. Number of meaningful digit in this number is 3 into 10 power 3. That is 1. Here you have not taken the zeros into account. This is called a trailing 0. But this 0 is in between the two non-zero digit. So this 0 is accountable, considered to be significant. Okay. So number of meaningful digit. Okay, sir, I have a decimal point. How to calculate? Decimal point. Say, for example, 30.25. 4. 32.60. This is the number. How many significant figures? 3. Number. Suppose this is a measured value, means number of digits we have 4. So 4. Sir, number means what is the meaning? Measured value means what is the meaning, sir? Measured value means 1, 2, 3, 4. Next, you are going to measure 4, 5 values, sir. One particular value you are getting 32.60. Another you might get 32.65. Another you may get 32.61. Another you may get 32.72. We don't know. So, if you take only 3 digit as significant figure, then while taking the average, you will get 4 digit answer. You should get 4 digit answer. Only 3 places you have measured means 4th place where you will use. So, measurement time, this 0 is also taken into account. Simply they are giving a number. How many significant figures they are asking means you can say this 0 is, it has got no value. So 1, 2, 3, that's all. 0.002. Before the decimal point, you have a 0, not significant. After the decimal point, you have zeros before the non-zero digits. This is called non-zero digit. 2 is non-zero digit. Before that, the zeros are not significant. So, number of meaningful digit is 1. Sir, I am writing 1.002, sir. Definitely you have 4. This is non-zero digit, sir. These two zeros are counted because before the decimal point you have a number. It is not 0. Okay. So this is the concept of significant figures. Rounding off. Rounding off is a simple concept. Suppose three values we have given, sir. Length, breadth, height. 1.1 centimeter, 0.06 centimeter. Breadth, height is 1.25 centimeter. 0.66 centimeter. Okay. Calculate the area, calculate the volume. Round off. Area is what? Length into breadth. Say this is a cuboid. Length into breadth. Multiply 1.2 into 0.066. Centimeter is 10 power minus 2. This is 10 power minus 2. So we have to put 10 power minus 4. You should get the answer. You are getting any answer. Let it be any value. 1.22 into 0.066 you multiply. You are getting some answer. Round off to 2-digit number. Why I have to round off 2-digit number, sir? How many significant figures here we have? 2 digits. Here how many significant figures we have? 2 digits. Answer also should be a 2-digit number. Sir, suppose I am having 1.066. So significant figure is 4. Significant figure here is 2. Your answer should be least number of significant figure digits. Which is least among these two? Length, 2 significant figure only. Answer also should be of 2 digits. Volume, 1.2 into 1.066 into 1.25. All the three you multiply. You are getting one answer. Round off to 2-digit number. Why I have to round off to 2-digit number? Out of the 3, length has got the least significant digit. How many digits we have? 2. So your answer also should be of 2-digit number. Round off. 2.66. Round off to 2.7. What we will say? 2.66 is more than 2.5, sir. I will write as 3. No. While doing the problems, if you want to round off closer to this value only, you have to round it off. Greater than 5 means next number, less than 5 means previous number calculation is absolutely correct. But everywhere you cannot use the same. Okay. And dimensional formula. Mass capital M, length capital L, time capital T, current capital A, temperature capital K. These are the 5. 99% we will use. Amount of substance, mole, luminous intensity, candela. These two fundamental physical quantities. Mass, length, time, electric current, temperature, amount of substance, luminous intensity. 7 fundamental physical quantities. That is called fundamental physical quantities. Unit in which it is expressed are called fundamental units. Dimensional formula means any quantity you express in terms of M, L, T, A, K, depending upon the quantity what you are using. How many times mass, how many times length, how many times T, depends. Capital M, capital L, capital T, capital K, capital A is a representation of a dimensional formula. Simple. Velocity. Velocity is distance by time. Distance is measure of length. Time is T. So LT power minus 1 is a dimensional formula for velocity. Force I want, sir. You can write. What is force? Mass into acceleration. MA. Mass is capital M. Acceleration is velocity by time. Mass dimensional formula is capital M. Velocity dimensional formula is LT power minus 1. Time is T. So I can write ML T power minus 2. Current I want, sir. Current I is nothing but charge by time. Q by T is called current. Charge by time. 1 coulomb by 1 second. That is called 1 ampere. Ampere is a unit. Coulomb, there is no dimensional formula for charge, electric charge. So current is capital A. That's all. Sir, MLT is not coming, sir. Not coming means you put M power 0, L power 0, T power 0, A power 1. Only ampere alone we have. Sir, velocity also we don't have mass. How will you write this? M power 0, L power 1, T power minus 1. You want to write M, you put power 0. That's all. Okay, so this is the basic thing. So many dimensional formulas or derived quantities we can write, but depending upon that, the problem what is being asked only we have to write.